Okay, everybody, let us finish up our Newton's second law little mini lab. On the screen, I've got the data for the trials I was able to run since my computer last crashed. I've got the rest of them on a piece of paper here. But again, this is the velocity versus time graph. This first line that you see here was the first trial I did. So this was just the cart and the fan. And then this one here is the last one that I did, excuse me, the second one that I did, where I put 4 mass bars on there, and this one here is in between. So I went from a mass of about ½ kilogram to 1.5, and then this one is 1 1/4, give or take. And so what you'll notice is that as I add mass, these lines get less and less steep, which means that the acceleration is going down. In order to get a little bit better idea of what that looks like, let us graph the acceleration versus mass data. And so here I've got mass and acceleration. I'm going to go ahead and type in the accelerations that I got. And you'll notice the graph on the right side is showing you those points over here as I enter them. And so far we see as the mass is getting bigger, mass is my x-axis, the accelerations are getting smaller. But 2 points isn't enough to really get a good mathematical trend. And so let's put in the rest. And what you'll notice is that those points will kind of start to curve. It's not a linear trend. And that should kind of make sense, because if it was a linear trend, it would eventually go below 0 and be negative. And there's no way I'm going to make something so big that when I push it, it speeds up in the other direction that I push it. And so these values will curve and approach 0, but never actually reach 0. So this is what we would refer to in science as an inverse curve. Let's see if I can add a trend line to that. So that's not the greatest line, but it'll kind of illustrate what the curve looks like. And so what we can say is that the acceleration is proportional to the inverse of the mass, or the acceleration is proportional to 1 over the mass. So if I were to take those same accelerations, I'm just going to come down here and copy them, and then do 1 divided by the mass, right here, where I just take my masses from up above and do 1 divided by those masses. Let's kind of copy that here. Let's make that a little bit bigger so we can see it. And let's kind of round these values off. There we go, that's better. Okay, so if I make a graph of 1 over the mass versus acceleration, then I should get a straight line. And that's pretty much what that looks like. You get a nice straight line when I do 1 over the mass and the acceleration. And fun fact, if I were to then get the slope of that line, which I can do by putting the equation on the chart, the slope of that graph actually tells me the force exerted by the fan, which is something that we'll figure out here in just a second. So what this is telling me is that the fan is exerting 0.07 newtons of force. Not a whole lot of force, but my cart is relatively small. So, fact number 1 that we've learned so far is that the acceleration is inversely proportional to the mass. In our next video, we'll look at how the force affects the acceleration. Till then, ta-ta.